Find the equation of the normal line g of x equals tangent of 2x at x equals pi eighths. So we will quiz tomorrow instead of today. Tomorrow's early release. Every class is about 26 minutes except for this class. Or should I say 36 minutes? No, this class is almost a full hour again. That's one of the cool things about when we do have early release, we don't have to miss time in this class. So we'll quiz tomorrow and then go from there. All right, so for the equation of any line, we need a point and a slope. For a normal line, we need the slope that's perpendicular to the tangent line. So we find the tangent line slope first, because that's what the derivative gives us, and then we'll get the normal slope. So first thing we need is, I guess, the y value. So g of pi eighths. You plug it in and you get tangent of 2 times pi eighths, which, of course, if this were a free response, believe it or not, you can leave it like that, right? That's considered an exact answer. That's the same as tangent of pi fourths. And you will have a little bit of trig on tomorrow's quiz. Tangent of pi fourths, of course, is 1, right? So if you want, you can rewrite it as an ordered pair. Sometimes it's just nice to see it like that. So there's the coordinate. And now we need the slope of the normal line. But first we need the slope of the tangent line, which first we need the derivative as a function of x. So g prime of x is going to be the chain rule, right? It's the derivative tangent of blob, which is secant squared of the blob, and then times the derivative of the blob generates another 2. So 2 secant squared of 2x. And now we can plug in your pi eighths. So g prime of pi eighths, I'm just going to bring the 2 in the front, and I'm going to call that secant of 2 times pi eighths is still pi fourths. And then I'm going to write it like this, squared. Okay, because I have to use it. That makes more sense to me. And again, free response, you can leave it like that. That's a legitimate slope. So secant of pi fourths. Let's quickly review pi fourths over here. It is square root of 2 halves, square root of 2 halves. And secant is the reciprocal of cosine, right? So it's the reciprocal of square root of 2 over 2. The reciprocal of square root of 2 over 2 is 2 over the square root of 2, which is actually, when you rationalize it, it ends up being 2 square root of 2 over 2, or just square root of 2. So that's a much nicer version to remember. So the reciprocal of the square root of 2 over 2 is just the square root of 2. So this becomes 2 times the square root of 2 squared, which of course ends up being 4, right? 4. And so that's the slope. That's the tangent slope. So m subscript tangent is 2. And now the normal line, right, is the perpendicular slope to 2. And of course, perpendicular slopes are opposite reciprocals of each other. So m subscript normal is negative 1/2. And now that I have my point and my slope, I'll say then the normal equation. Again, getting in the habit of labeling things. The normal equation is in Taylor form, y equals the y value plus the slope, which is minus 1/2, x minus the x value, pi eighths. So again, that would be a good place to stop on a free response. But of course, on a free response, if you so chose, you could leave that as your y value, and then you could write your perpendicular slope as the opposite reciprocal of that, which is kind of gross. Now let's take it one step further here. If this were a multiple choice question, it might be in what's called general form. So here's another version for a line. General form is of the form ax plus by equals c, where a, b, and c are element of the integers, which means there's no fractions. Okay, that's what that means. Other than that, you have your x's and y's on one side. So once you set up your equation, whether you need it in slope-intercept form or in this case general form, you still can set it up with Taylor form. Now, what I would recommend, if you do have to get it into general form, since you have 2 denominators, is just to get rid of your denominators by multiplying both sides by the LCM. Now, if you want to distribute first, that wouldn't be a bad thing to do here because you have a fraction on the inside of the parentheses and the outside of the parentheses. So let's go ahead and do that. Y equals 1 minus 1/2 x, and this becomes plus pi 16ths. Okay. Now, to clear out the fractions, unless you just absolutely love working with them until the very end, multiply both sides by your LCM of 2 and 16, which is what? 16, right. So 16 on this side, and notice the parentheses, 16 on this side. So you get 16y over here, and now you just distribute to everything. So you get 16. This is going to be minus 8x, and then this will be plus pi. So that looks pretty nifty. And now you just bring your negative 8x across, positive 8x plus 16y equals, and then you got 16 plus pi. So not the nicest looking constant, but it is what it is. And that could be an answer. Now, sometimes you might have like, one negative term and two positive terms, or two negative terms and one positive term. If you see if you don't see your answer as an answer choice, don't panic. Just realize that you may have collected things on different sides of the equal sign. Just multiply both sides by -1 and distribute. So here's the other version of the correct answer. Negative 8x minus 16y equals negative 16 minus pi. That would also work. Now that's way too many negatives for my liking. So if I were writing a test, I wouldn't do that. Okay, so that's how you get it in a general form. Just get rid of your fractions, multiply both sides by LCM. So it's kind of like the equation version of lick 'em over lick 'em. It's lick 'em on each side. All right, normal line. Cool. Questions on that? Little bitty application of the chain rule. Tomorrow your quiz will be just over the chain rule. All right. Let's look at example 5. Example 5 is good because a lot of these look very, very similar to each other, but they are in fact different functions. And some of them require chain rules, some may not. We want to find the derivative and then simplify. Okay. So they all involve cosine, they all involve 5, they all involve x. So here we go. Letter A. Step 1 is to take inventory, right? As always, rewrite it if need be, add grouping symbols if you need to. What are we taking the cosine of? Just the 5 or the 5x squared? 5x squared, yeah. So again, you don't have to do this, but I like to do that, right? So you have cosine of the blob. So this is going to be a chain rule again. So the left side is f prime of x equals, and we work from the outside in. The derivative of cosine of blob is negative sine of the blob, and then times the derivative of the blob, which is 10x. Yeah. And then to rewrite it, to simplify it, you can bring the 10x in front, negative 10x sine of 5x squared, and then you wouldn't need parentheses around the 5x squared. By default, we always assume the very first term after a trig function or after a natural log is going to be the argument or the angle. Okay, the very first term and the very first term only. Now that's the quickest way to do it. Let me show you another way to do it that I was going to do in the very beginning. You remember Leibniz form with the mousetrap in the beginning with the DD everything? Here's what this would look like in Leibniz form. I'm going to first of all call f of x y equals. So let's let y equal cosine of 5x squared. What we're going to do is we're going to temporarily introduce a third variable. We're going to let u, which is just some dummy variable, we're going to let u equal the inside function. This will be more important when we start going backwards in the second half of the house of calculus. Okay, so we're going to let u equal the inside function. And now this becomes y equals cosine of u. All right. Now, what I'm after, of course, this is what I want. I want the derivative of y with respect to x. Okay. But here's what I can do. I can get there by doing the following. The derivative of y with respect to x could equal the derivative of y with respect to its new variable u, and then multiplying by the derivative of u with respect to its variable x. And you can see that the du's will divide out, giving you dy dx. So all this does is it gets rid of the chain, it gets rid of the chain rule, because you now split it into two separate derivatives. Both of them are pretty straightforward. So here we go. The derivative of y with respect to u is going to be negative sine of u, right? And the derivative of u with respect to x is 10x. So neither one of those individual derivatives required the chain rule. They were just straightforward derivatives. And now if I string them together, so the derivative of y with respect to x is going to equal, I'm not going to write that again, but it's dy du, which is negative sine of u, times du dx, which is 10x. Well, there's only one problem with stopping here, right? U was a dummy variable. It was a temporary placeholder for a quantity that was in terms of x. So all we got to do is substitute it back in. And when I do, I'll bring the 10x in front, negative 10x times sine of u. And what is u? U is 5x squared. So you do get the same answer. So of course, it's a lot more labor intensive. It's a formal process, but it does eliminate the chain rule, right? The two derivatives, the actual calculus part, were straightforward derivatives. All right. So yeah, if you want to do it that way, feel free. U substitution is what this is called, and it's a pretty slick thing. We'll utilize it a lot in integration, especially in the beginning when we're trying to help ourselves see patterns. But there are some times where it's absolutely required, and I'll show you. We'll cross that bridge when we get there. How about that? All right, so there's A done a couple different ways. All right, letter B. We got f of x is cosine of 5x squared. So again, notice the parentheses are already there, and they're grouping the cosine of 5 together separately from the x squared factor. So is this going to be the chain rule or the product rule or neither? Did we have tutors show up?
Yeah.
We did. Nice. 2 of them? 3 or 4?
Yeah.
Nice. It's catching on. That's good. Did it feel good? Did it feel good?
At first it was confusing, but then I remembered how to do that.
Oh, nice. See, it's good for both. It's good for both parties. All right. This cosine of 5, do you see a variable in there at all? No. This is a constant, right? Constant. This is the cosine of 5 radians. Is that going to be a positive or a negative number? Cosine of 5 radians. Yeah, 5 radians is somewhere right there in quadrant 4. It should be a positive number. So remember, how do we take the derivative of a constant times x squared? Multiply and subtract, right? It's just the power rule. Power rule. So 2 times cosine of 5 is 2 cosine of 5 times x to the first. Now, again, if you leave it like that, that's going to look like cosine of 5x. So you need to either put parentheses around what they started with the constant multiple, or you put them around the x, or both. Okay. So very, very important. That's why grouping symbols are important. They help clarify what you mean. So there you go. Cosine of 5 is just a number. It goes along for the ride. All right, letter C. Now we have cosine of 5x squared. What are we actually squaring? Just the 5x. Now, simplify when? Late and never? Early and often. So if you want to do this as like a double chain rule, you can, but I think I'd rather just simplify it. 5x quantity squared is the same as 25x squared, right? 5 squared x squared. So now we just have one layer on the chain rule. Makes it a lot easier. So here we go. F prime of x is, the derivative of cosine is negative sine of the blob times, why did I leave such a big space there? Well, multiplication is commutative. So at some point, when you're doing the chain rule, you can keep multiplying by the derivative of the inside function off to the right-hand side and then rewrite it, or you can kind of anticipate that you're going to do it and multiply by the derivative of the inside function on the left side. The problem is because we write left to right, you'll have to leave a space there. What's the derivative of 25x squared? 50x. Boom. And there you go. Now I don't have to rewrite it. So negative 50x sine of 25x squared. That's your answer. Now, one little word of caution here. Caution. If on the calculator you type in cosine of 5x close parentheses squared, your calculator interprets this to be cosine of 5x quantity squared. Okay, when you close the angle and then square it, your calculator thinks you're squaring the entire function. Okay, that's just on the calculator. And I don't know why they programmed it like that, because that's not math print. That's not how math works. They are actually not equal in the real world. Okay, so keep that in mind. If you could use that to your advantage, right? If you were trying to type in cosine squared of 5x and you didn't want to have these extra parentheses, cosine of 5x squared, you could actually use the calculator's programming flaw to avoid one set of parentheses. Now, to me, it's not worth reinforcing something that's incorrect, because your brain may not know that you're pretending or making a joke or whatever. I would just say, hey, type in those extra set of parentheses. But anyway, be aware of that. Your calculator does that, but we don't ever write it like that on, on paper or anything. If we're ever writing it like this, we're going to always interpret it to just be this, right? Cosine of 5x squared, we interpret it to be cosine of 5x squared, like that. But we don't need those extra set of parentheses except for clarification. So this is true, and then this is your calculator's lie. Let's put that there. It's a calculator lie. Okay, A, B, C, D comes next. Cosine squared of 5x. This again is the one where if you're one of those people where you're like, I don't have to rewrite it, I think I can handle it without it, and you miss it, then shame on you, because this is the one where a lot of people miss the outside layer. So rewrite it. We're actually squaring the entire trig function, cosine squared, then cosine, and then the 5x. So 3 layers, right? 3 layers. With 3 layers, we have 3 links in the chain, and the first link in the chain is the one people miss, right? 2 blob to the first, and that's cosine of 5x. Do we need the 1 right there as an exponent? No. Will I always put it? Yeah, I do. Because again, when I come back and I see the 1 there, I know that it's there on purpose. Whereas if it's not there and it's supposed to be something different than a 1, you're not going to catch it, right? Because it could be an oversight. So to the first power, and then times the derivative cosine is negative sine of 5x. How is that for notation? No. Right? Dot negative is no good. Okay, now the GR goes away. And then times the derivative of 5x, which is 5. And we saw one like this. You can actually use the double angle identity to condense it, or you can just bring the negative 5 out front with the 2 and call it negative 10 cosine 5x times sine of 5x. There you go. A, B, C, D, E comes next. Y'all do this one on your own. Go. All right, so for one like this, we're taking the derivative. There's a couple of things I would do. For sure, I would rewrite the radical as a fractional exponent, but because it is a ratio and I have a constant multiple in the top, I would also bring it to the numerator so I don't have to use the Hody-High rule. Not that I don't like the Hody-High rule. It's actually my favorite rule to say, right? Hody-High minus Heidi-Ho over ho-ho. So this is going to become cosine of 5x, adding the parentheses around that. And then it's to the negative 1/2 power. So that's bringing it to the top and getting rid of the radical all in one. So now we have 3 layers working from the outside in, f prime of x on the left. You get negative 1/2 blob to the negative 3/2 power. Again, notice if you do notice this, take notice now if you haven't. I tend to write all of my fractions with the horizontal division bar just because it's a lot safer that way. I know if it's just a number divided by a number, you can use the slash like that. But sometimes if there's more than one term or more than one factor in the denominator and you use the diagonal slash, you have to put in parentheses, and if you don't, it's wrong. So I just try to do it every time. There you go. And then I'll write the blob in here, cosine of 5x. Times the next link in the chain, the derivative of cosine is negative sine of the blob, times the derivative of the innermost blob is 5. Okay. So there's the calculus part, right? We cleaned it up with algebra to be able to take the derivative. Calculus came, calculus went, right? One line. And now algebra cleaning it up again. So let's see what we got here. Hey, look, a negative times a negative, that's a positive. I like that. In the numerator, I'm going to have a 5 times sine of 5x, no longer needing the parentheses. And in the denominator, I'm going to have a 2, and then I'm going to put it back under a square root, and it's going to be cosine cubed, which I can then write in condensed format once again. So there it is. The cubed? Absolutely. Yeah. You can leave it like that if you'd like. Okay. And if you need more lines to clean it up, feel free to take more lines, right? Inch by inch, it is a cinch. I'd rather you take more lines, get it right, than to try and do it in one line and get it wrong on your cleanup. Just make sure you have the right notation all the way down. So f prime, f prime. All right, and then the last one on this section, the derivative of cosine of 5. Is it negative sine of 5? Yeah, it's 0. Okay. Now, if you wanted to use the chain rule, you could. Watch. Cosine of blob. The derivative of cosine of blob is negative sine of the blob times the derivative of the blob. What's the derivative of 5? 0. And then 0 wipes everything out. Or you just realize from the beginning, hey, cosine of 5, that's just a number to begin with, and its derivative is 0. Okay. All right, cool. Questions on number 5? Number 6. Very similar to the warm-up, but easier because we only do the tangent line. Find the equation of the tangent line to this graph at pi. All right. I think this is another one for y'all and y'all alone. On your mark, get set, go. All right, couple walking around. It's good to see, you know, some things that y'all are doing, but let me talk you through this one because it's already done up here. You do have two terms, right? They're both trig. 2 sine of 1x plus cosine of 2x. So remember, first of all, that if the angles are more than 1x, you can't mess with those unless you use an identity, like the double angle identity or the composite identities. You can't just like pull a 2 out. Like doesn't work the same as factoring out. So it's kind of stuck in there unless you want to use the double angle identity for cosine of 2x, which of course you should know. It's cosine squared minus sine squared of 1x. It's almost like Papa Pid. So first thing I did, since we just have an x value in an equation using the right notation, I plugged it in for x into the original function to find the y value. 2 sine of pi plus cosine of 2 pi. Free response answer, that's good, right? But we do need to know the unit circle. We do need to know the unit circle. All right, so pi is over here at 180. Is that 180 to y'all? Yeah. Yeah. And the ordered pair there is -1, 0. So the sign is the y, right? Sine y, right? So it's 0. And then cosine of 2 pi is coterminal with 0. The ordered pair there is 1, 0. So the cosine of 2 pi is the same as cosine of 0, which is 1. And we get 2 times 0, which is 0. And then 0 plus 1 is 1, right? And then I listed it as an ordered pair. I just like seeing it as an ordered pair because, I don't know, it makes more sense to me. F of pi equaling 1 still has all the information, but I don't know, just an ordered pair, x comma y, right? So pi comma 1. You don't need to do that though. And then the derivative, right? 2 terms, we're gonna have 2 terms. The first one, the 2 goes along for the ride. You don't need to use the product rule here because it's a constant multiple. So 2 times the derivative sign is cosine. The next one is the chain rule. The derivative of cosine is negative sine of 2x times the derivative of 2x, which is 2, and I went ahead and wrote it in the front, okay? And so there is your derivative. Once you have f prime of x, and not before, then you can find f prime of pi, and you get 2 cosine of pi minus 2 sine of 2 pi. That would be an okay slope on a free response. But we get to evaluate it. Cosine of pi is actually -1, not +1, times the 2. And then sine of 2 pi is 0 again. So carefully, I just showed more steps because I had the time. -2 minus 0, you get -2. So there's your slope of the tangent line. The normal slope would be +1/2, but the tangent slope is -2. So now we just drop it into Taylor form, which is y equals the y value plus the slope times x minus the x value. I went ahead and called the tangent line equation instead of y, I called it L of x. We're going to do that later on in the year because we're going to use the tangent line. You might want to give it its own name or just call it y for now. So L of x is the y value of 1 plus the slope, which is -2 times x minus the x value. So remember, the Taylor form has one minus sign in the formula. It's x minus the x value, but it's plus the slope. The slope will only be negative in the equation if the slope itself is negative. Yeah, Lauren. What's that? Go ahead. Oh, that came from the chain rule because I didn't put parentheses, but cosine of blob, right? Cosine of blob is negative sine of blob times the derivative of the blob. I did do the chain rule on that. Okay. Yeah, don't skip the chain rule. Watch this. The derivative with respect to x of cosine of 2x is negative sine of 2x times the derivative of 2x, which is 2. Everyone okay with where that 2 came from? Anytime you have a blob that's more than plain old x, you'll have a chain rule. You did the product rule on the first one? Yeah, yeah. Let's talk about that because I saw like several people do the product rule. Here, if we got 2 times sine of x, if you want to elevate 2 to its own function status, you can. And you can do the product rule, right? Product rule, 2 factors, you're going to have 2 terms. The derivative of 2 is 0 times sine of x goes along for the ride, plus 2 goes along for the ride times the derivative of sine is cosine. That's fine. If you want to do the product rule, that whole first term is going to go away and you're going to be left with 2 cosine of x. So that's why, you know, moving forward, if you want, and I would recommend it, just treat constant multiples as riders. They're there in the beginning, they're there in the end, they go along for the ride, okay? And then again, the chain rule, I was already leaving a space and pulling it in the front, but if it's too early for y'all to do that, no problem. Just continue to multiply it on the back end and then take an extra line to rewrite it in the front. When you get back, we're going to finish the notes, and we should finish it pretty easily with y'all's cooperation, which is always appreciated. Have a fantastic lunch, if not better.